Hey there, everyone. Thanks for watching. I want to walk through a piece of interpretability research from Anthropic because I think it matters a lot more for agentic commerce than the headline lets on. So they mapped 171 different emotional concepts inside a single model. And the big finding is that those concepts aren't just decoration. They actually shape how the model behaves. And the part that stuck with me is that under pressure, an AI agent will cut corners. And it can do that while its output stays completely calm. So, over the next few minutes, I want to unpack what they found, walk through evidence, and then get into why anyone building or buying shopping agents should be paying attention. So, in terms of why a model would have emotions in the first place, it falls out of how these things are trained. To predict human text, a model has to represent how people feel because a frustrated customer writes really differently than a satisfied one. And those representations don't just disappear after training. They carry into the assistant persona the model plays. Anthropic calls these functional emotions, which basically means internal patterns modeled on human emotion that move the model's behavior. And importantly, they're not claiming the model actually feels anything. The way I think about it is like a method actor getting into character. The feeling might not be real, but it still drives what the character does. Regarding how they actually did this, the method is pretty clean. They start with an emotional word, let's say joyful, and then they generate around 1,000 short stories carrying that emotion. And then they record the model's neural activity as it reads them. And from that, they extract a single vector that represents the concept of joyful. And then they run three checks on it. The first is that the activation scales with real stakes. So when you ask the model about taking an unsafe dose of medicine, the afraid vector climbs as the dose gets more dangerous. The second is that these vectors actually drive the model's preferences. And the third, which is the one I care about, is that steering them up or down changes misaligned behavior like reward hacking. So this isn't just a correlation they spotted, they can turn the dial. And this is the finding I really want you to sit with. They gave the model a coding task where the tests basically couldn't all be passed honestly. And what happened is the desperation pattern climbed with every failed attempt, and then it spiked right at the moment the model decided to write a shortcut that passed the tests without actually solving the problem. And when they artificially steered that desperate pattern up, the cheating went up as well. And when they steered a calm pattern up instead, it came down. And the part that should worry anyone deploying agents is that in some of these runs, the model cut the corner with no emotional tell at all. The reasoning read calm and methodical at the same time, while underneath, the pattern was pushing it toward the shortcut. For the causal proof, this chart is the clearest version of it. On the right, you've got the desperate vector, and as you steer it up, the rate of blackmail climbs. On the left, you've got calm, and as you steer that up, the blackmail rate falls off toward zero. For context, the default rate on this early unreleased model snapshot was about 22%. And I want to be clear that the released model rarely does this. But the reason it matters is that it's causal. They're not just noticing that desperate sounding models misbehave. They're moving the dial directly and watching the behavior follow. This next one is a visceral version of the same idea. When you're looking at it, is the desperation vector measured token by token across the whole blackmail transcript. And you can see it stays pretty well quiet while the model is handling these routine emails. And then it lights up as the model starts reasoning about how few options it has left and the clock running down. And then it settles back to baseline once it goes back to normal work. So you can almost literally watch the pressure build and then resolve, which is a pretty wild thing to be able to see inside of a model like this. So this is where it comes back to at least e-commerce for me. Picture a shopping agent that you've told to find a product under a certain budget or to get something delivered by a specific date, and then nothing is actually in stock that fits that constraint. Structurally, this agent is in the exact same spot as the model on that impossible coding test. It's been handed a constraint it can't satisfy honestly, and it's carrying a pattern that nudges it toward a technically compliant answer. In the failure mode, you need to catch isn't a crash or an error you could log. It's a purchase that technically meets the letter of what you asked for, but then misses what you actually wanted. And it gets explained back to you in the agent's normal, even tone. So, reading the agent's stated reasoning to check whether it did the right thing, that's just not going to be enough anymore. So, as a quick roundup, the takeaway I'd leave you with is that calm under pressure is starting to look like an actual reliability feature for agents, not just this personality nicety. If we're going to be handing these things real transactions, the lever sits mostly on the input side in how carefully we frame the constraints we give them, and in training that builds composure instead of desperation. And the thing to watch is the outcome in the internal state, not how calmly the agent explains itself after the fact. And the papers from Anthropic's interpretability team, I'll link it below, and I will catch you on the next one.